Yep. P5 combining functions to make new functions. Okay. Definition. Oops. If f and g are functions, then for every x that belongs to the domains of both f and g, we define f plus or minus g of x equals to f of x plus or minus g of x, and the f times g of x equals to f of x times g of x. Okay, and the f over g of x equals to f of x over g of x, and the where g of x is not equal to 0 function, and the multiplying by c constant f function equals to constant times f of x function. Okay, and let me give you some example. About this combining functions. F of x, okay, and equals to square root of x function, okay, and the g of x function equals to square root of 1 minus x function, okay, and the function formula and the domain. And the f function, which is square root of x, okay, and its domain will be 0 to the infinity half open interval, and the g function, which is square root of 1 minus x, okay, please attention, minus infinity to the plus 1 half open interval, and the 3f function, okay, and that means 3 times square root of x, so domain will not be changed, and 0 to the infinity half open interval, and the f plus g, this is the combining f and g function, and what can we say about this? And our formula will be square root of x plus square root of 1 minus x. And what can we say about the domain of f? And we can say intersection of both domain, okay, and this will be 0 to the 1 close interval, okay. And the f minus g, this will be square root of x minus square root of 1 minus x. So domain will be same, and the f times g function, so this will be square root of x times 1 minus x, okay, and the domain will be same again. And the f over g function, which is square root of x over 1 minus x. So maybe this part must be parenthesis, because of when you put one value, the numerator will be 0, so it's not correct, okay. So let me continue. G of f function, okay, and the g of f function will be square root of 1 minus x over x, okay, and attention for the denominator, and the denominator must be subtract from the whole domain, and this will be parenthesis 0 comma 1 close parenthesis, so half open interval. And these are some examples by combining functions which are f of x and g of x function. And let's talk about some composite functions. And if f and g are two functions the composite function which is f o g is defined by f composite g of x equals to f of g of x, okay, and the example, f of x equals to x squared and the g of x equals to 2x minus 3, and the f composite g of x, it equals to f of g of x by the definition, okay, and it equals to f of g of x was 2x minus 3, and when you put 2x minus 3 into the x squared, you will obtain 2x minus 3 square, and which is equal to 4x squared minus 12x plus 9. I'm sorry, plus 9. And let's talk about g composite of g composite f function, and that will be g of fx function. So g of x squared, and it will be 2x squared minus 3, right? And the f composite f function, it is f of fx function, and it will be f of x square, so it will be x square to the power of 2, which is the x to the power of 4, and the g composite g function, so it's equal to g of gx function, and the g of 2x minus 3, so it will be 2 times 2x minus 3 minus 3, so it equals to 4x minus 9. And the piecewise defined functions, another important functions, piecewise defined functions. Most popular piecewise defined function is absolute value function, and don't forget we define it by the plus x if x is larger than or equal to 0, and the minus x if x is less than 0. So this will be like that, we know it. And another piecewise function the hillside function, or we can call it unit step function. Okay, and this is hillside, that means h of x function, it equals to 1 then if x is larger than or equal to 0, and the 0 if x is less than 0. And when you sketch it on the Cartesian coordinate system, you will obtain, okay, like that. Okay, x, y, and this is the hillside function. Okay, and let me continue with the least integer function. And the function whose value at any number x is the smallest integer greater than or equal to x is called least integer function. And it can be defined as this symbol, and the n value if x is equal to n, and n is element of integers, okay, and it equals to n plus 1 when if x is larger than n and less than n plus 1. Of course, n is element of integers. So let's sketch it. And this point is -1 on the x-axis, and this is +1, and this is, there is hole, okay, on the +1, and like that. I'll write the real value of them. Please wait me some. Okay. And these values are +1, +2, and this +1, and this is +2, -1, -1, and -2. Okay, this is the at least integer function. Okay. And this is P6. Polynomials and rational functions. Definition: a polynomial is a function P whose value at x is P of x equals to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus 3 point, it goes on. That means a sub 2 x square plus, okay, a sub 1 x plus a0, okay, and where a sub n comma a sub n minus 1 comma a sub 2 a sub 1 and a0 called coefficients of the polynomial are constant and if n is larger than 0, then a sub n does not equal to 0, and the n is highest power of x in the polynomial. And we can call it degree of polynomial. Example: about the division algorithm. Okay, and the numerator part of the polynomial is 3x cubed plus 5x squared minus 3 over x squared minus 1. Okay, and this means you must divide it by the x squared minus 1. So 3x cubed plus 5x squared minus 3, okay, division by x squared minus 1, and when you multiply x squared by the 3x, you will obtain the 3x cubed. So we can write 3x here and the result part here, and the 3x cubed minus 3x. Okay, when you subtract it, and the second part's sign will be changed, minus to the plus, plus to the minus, so this will be minus and this will be plus, so this parts will be cancelled. So 5x squared, okay, and the plus 3x minus 3, and now you can write the plus 5, because when you multiply it by the x squared, you will obtain the 5x squared and the minus 5. Okay, when you subtract, and the signs will be changed, so this part will be cancelled. So 3x, okay, plus 5 minus 3, and it will be plus 2. Okay, and now we can write it 3x plus 5, okay, and the plus 3x plus 2 over x squared minus 1. This part, okay, equals to this. Okay, and let me continue with the roots and the factors of polynomial. The fundamental theorem of algebra states every polynomial of degree at least one has a root. The fundamental theorem of algebra states every polynomial of degree at least one has a root. So, example, p of x polynomial equals to 3x minus 6, so its degrees is 1, so root x equals to 6 over 3, it equals to 2, and another polynomial which is the 5x squared minus 100, and the roots, okay, x equals to plus or minus, okay, 2 times square root of 5. Okay, and let me write the factor theorem. The number r is a root of the polynomial p of degree not less than 1 if and only if x to the r is a factor, x minus r is a factor, I'm sorry, of p of x polynomial. Example, what is the degree of p of x equals to x cubed times x squared plus 2x plus 5 squared polynomial, and what are the roots of p, and what is the multiplicity of each root. And if we expand p, okay, and assume that this is x cubed and the x squared to the power of 2, and that will be, okay, x cubed times x to the power of 4, so it's equal to x to the power of 7. So we can say, okay, p has, okay, degree 7, okay, and the factor x cubed, that means x minus 0 cube, and it indicates that 0 is a root of p polynomial having multiplicity 3. Okay, and the other part, x squared plus 2x plus 5 squared, okay, so it equals to x plus 1 squared plus 4 squared, okay, and it equals to x plus 1 plus 2i, which is the complex number, and x plus 1 minus 2i, and the squares. And after that, we can say P has 7 roots, and 0, 0, 0, and the 0 has multiplicity 3, and the minus 1 minus 2i, and the minus 1 minus 2i, and we can say minus 1 minus 2i has multiplicity 2, and the other part minus 1 plus 2i, and the minus 1 plus 2i, so minus 1 plus 2i has multiplicity 2, and when you addition all of the multiplicity, you will obtain 7, which is degree of this polynomial. And let me continue with the roots and factors of quadratic polynomials. A times x squared plus bx plus c equals to 0, and it has two solutions of this quadratic equation where a, b, c constants, and a is not equal to 0, so x equals to minus b plus or minus square root of b square minus 4 times a times c over 2a, okay, and the quantity d equals to b square minus 4 times AC, okay, and the D can be defined by or can be shown by delta, and it is called the, as you know, discriminants. Okay, so this is important for us, and let me give you 10 minutes break, please, and after that we'll continue with the last subtopic of the preliminary chapter. Okay.